So hey everyone, this is your Aman. In this series, we just take class 12 mathematics first chapter, that is relation and function, and this lecture is lecture 2 of our relation and function. And I'm just giving you the advice that you just make sure you just learn the first lecture for this chapter only, and then after you just take this lecture at a time, because these all the whole series are linked with each other, and it may make easy to you understand the further lectures. Okay, so basically the lecture 2 name is types of relation. Without any delay, let's start today's lecture. Okay, so students, there are various types of the relation, and I can just say the important type of the relation for 12th class only, that is, you can say the 3 types relation, that is what reflexive, symmetric, and the transitive one. Okay, so in this actual lecture, we just revolving around these 3 types of the relation, and moreover, like focusing on the definition part in this more and more, we can just take examples, more and more example, not so much definition, because for reflexive, for symmetric, and for transitive, you must aware and you must practicize all those examples, all those questions for more much understanding for these types of the relation. So we just take more example but less theory, but the relatable theory. Okay, so for these examples, I'm just taking the reference. Okay, so when I take the example for this reflexive or symmetric and transitive relation, I just take from the past lecture, that is our lecture first. I'm just take this one or two more scenarios. Then if I can say the A set here, okay, there have A set, and I can say the 1, 2, and 3 and 4. Okay, these are the elements in the A set, and I can just say there have a relation on A. Okay, so what does that mean? Actually, with the reference of the lecture first, it means that the relation actually defines on what? On my A set. So whatever the pair set that can be obtained with some condition, maybe it's must both the coordinates, or I can say both the elements on that pair should be in my A set here only. Okay, so I just found that relation or the pair of that relation which taking from the reference on my original one set. Okay sir, that is what we just learned in our previous lecture. Okay sir, okay, let's take okay, so basically with the help of this, let's take the reflexive one. What is exactly reflexive one? Okay sir, okay, let's take, there have some relation, and it's contain what, some pairs here. Okay, so what kind of the pairs? I can say 1 1, okay, I can say the 2 2, I can say the 3 3, okay, I can say 4 4 here, and I'm just taking some more, and then say 3 2 here, 4 1 here, and maybe the 2 3 here. Okay, so this is what about I am just taking a hypothetical relation which is obtained from my A set only. Okay sir, no problem. Okay, let's check the definition here. So we can just take the relation which is A be a non-empty set, no problem, and then a relation on A is said to be reflexive in what condition? Okay, let us know. Okay, so for reflexive condition, the relation have identity pair must have in our relationship for whole set A. So what is the identity relation? We have just learned in our previous lecture. The identity relation is that our, if I can say the A comma B are my pairs for the relation set, so I can say the A and A equal to B here. That's the elements of A and the elements of the B. The elements of the first coordinate element and the second coordinate element must be same here. So with the help of these sets, there are only 4 set of the identity element. What set of the identity element? That is 1, 1, 2, 2, 3, 3, and 4, 4. So it is must. What? It is must. These 4 sets, or I can say these 4 pair are in my relation. If these 4 pair actually in my relation, then I must call this relation as a reflexive relation. If there are some more other elements that is are in extra pair, that is an extra, it's okay. But if there are anyone are not in there, then I can say this relation actually not in my reflexive one. Okay sir, so sir, here is the idea. We can just say all the identity pairs which derives from my A set actually, which should be in my relation. Okay, so that relation actually must be called the reflexive relation. So for reflexive, we just take a reference from my original set, that is my A set. So what does this say? Actually it says if A comma A belongs to what in my relation? A comma A what? The equal elements belongs to my relation for each A belongs to, for each A means they have something that each A means you take all the elements from A which belongs from all the elements from A, my set here, okay, from the original set here, then I must call this relation is reflexive relation. This is all about what, that is if A actually relates with A, okay, this A comma A means actually A relates with A, and for each A belongs to my original set 1. Okay sir, that's all. So we just take for all. Okay sir. Okay, if I take the symmetric one, so what is the symmetric? Okay, let's take the this symmetric as a what in our relation. Okay, reference as our relation. Okay, let's see. Okay, so for symmetric part, what actually symmetric says? Symmetric actually says if AB, this is the condition, if AB is on my relation, if A comma B is on my relation, then it must be reverse thing, that is B comma A, something that is B comma A also in my relation. So if the all elements are there, then its reverse pair are also be there. If that one particular pair are be there in my relation, then its reverse pair are also be there. If this is happen, then I can say this relation exactly called my symmetric relation. That is all about. Okay sir. It means if the one of the pair have no reflection, no reverse here, one of the pair that is no reflexive here, then it must be the relation is what, not symmetric. Okay, so this A and B actually belongs to what? This A and B actually belongs to my A set. That is very true. So that is A related to B. Then it implies if A related to B for symmetric now, that implies B must be related to A here. Okay, so that is what about symmetric thing. Okay, let's see. Okay, let's say the transitive one. So but if I can take the symmetric one as a one condition, then if I take the one condition, what is the one condition? The A comma B are here, then it must be B comma A are here. Okay. For transitive one, we just say there have A comma B in the real function, and take this values are same. Take these values and say this is also are in my relation. Okay, also are in my relation. And for this we just take this element and this element. For implies actual result, I can must be say this A comma C are also in my relation. Okay sir, this is what something which is out of bound here. Okay, let's see. If I take A comma B as in relation, that must be in my relation. Okay, B comma C, that is also in my relation. I just find the two pairs here. Okay, and then it implies that this with the common elements are gone, and I can say A comma C are also in my relation. If this can be happen, then I can say simply that this is what, this is my transitive relation. This is my transitive relation. Okay, so this is all about the theory part that I must be giving you at this if I take this theory as well now, so this is the enough theory for you. Okay, if I can say, okay, so what can I do? If I can say sir, if I take the relation, if I can say the relation that is maybe 1 1, okay, maybe 2 2, and there are only 4 4, and maybe some other element that is 3 2 and 3 1. Okay, with many conditions there are the relation formed. Okay, you can say sir this is the reflexive relation. Why? You can say sir 1 1 here, 2 2 here, 4 4 here, these all are entity part. So is this relation? So you can say no. I can say no. Why? Because there are no 3 3 here, na, and I have must be all the elements as identity pair, all the elements as identity pair. So you can say sir the 3 3 are not be there, that's why this is not a reflexive part. So for what exactly, for this reflexive, symmetric or transitive thing, you have to find, that is the note part here. What note part here? You have to find contradictory, maybe the spelling is wrong. Okay, the contradictory or false condition you must be find. Okay, you must be find contradictory only one contradictory or false condition. If you able to find only one of false condition, then I am just saying this whole relation actually not my reflexive, not my symmetric one, or not my transitive one here. Okay, so that's how the things work here. Okay, so you just find one false condition. If you cannot find that false condition, then I am just saying this is my reflexive relation, symmetric relation, and transitive relation. So this is all about the definition, I can say, the theory part for our types of the relation. Okay, let's comes on the quotients thing. Okay, let's take the examples. Okay, Okay, there have very theoretical example, and I can just say the mind doctrine examples. Okay, okay. Let's say let L be the set of all lines in the plane. Okay, L be the set of the all lines in the, there are the set, and there have say L is my set of all lines. Okay, all lines on the plane. Okay, there may be, okay, so this is considered there may be intersecting line. Okay, there may be intersecting line. Maybe many lines are intersecting with each other. There may be parallel lines are there. There may be parallel lines there. There may be perpendicular lines are be there. Okay, there may be perpendicular lines are be there. So these are what? These are the some set of lines that must be in my L set here. Okay, okay. So R is what? R actually be the relation on L. Okay, so is this like my A set? Because this is what say that is R on L. R on L, basically we can say the be the relation in L. So R actually take all the values from my L set here. Okay, no problem, sir. So defined as what R exactly defined as? R exactly defined as L1 comma L2, and I am just take L1 is perpendicular to L2. Okay, so R actually define only one set, or I can say the similar set, that is L1 and L2. L1 and L2 like take line 1 and line 2, and these line 1 and line 2 are perpendicular lines. Okay, no problem, sir. No problem. So for symmetric, transitive, reflexive, now there are many questions. You have to show your symmetric. This is a symmetric, not symmetric, reflexive, not reflexive, transitive or not transitive. Okay. So what step you must take on? You just firstly given your heading the reflexive one. So firstly in this order we just given the reflexive one firstly. Then you just must given the symmetric one. Then after that you just must given the transitive one. So here I have a following order. You must follow this order. This is how you must taken as a serious note in our types of the relation. Okay, okay, no problem, sir. Okay, sir. If I can say the reflexive one, I can just and you can write as it is in your 12th class board, or whatever you whatever the writing paper you have do for your in your 12th class or after the 12th class. That is all I can do here. Then you can just copy paste in your what exam sheet. Okay, okay, sir. Okay, let's say the reflexive one here. So what is the reflexive one? I can just prove that is this one is reflexive or not. Okay, okay. Let's say if it is L1 comma L2. So for the reflexive one, the line should be identical. Okay, the reflexive one, the line should be identical. So I can say let L1 comma L1 in my relation. Okay, if this let thing are actually not in are actually wrong, then I can say this is not my reflection thing. Okay, let's say if this L1 comma L, but identical lines are in my R. Okay, if this is happened, then it must be like this. It must be like this. It must be with the condition like what? L1 is perpendicular to L1. Because both the things, or you can say both the values are taken from your this coordinate pairs now. So I can say L1 is perpendicular. So it must be L1 is perpendicular to L1. So is this very logical? Is any line should be, or I can say maybe perpendicular to himself? You can say no. So I can just write out the given statement, or you can make your own way. I can just make this condition actually not satisfy with above statement. This condition is not satisfied with above statement. I can say the L1 is not, or I can say that is L1 is not perpendicular for himself. L1 is not perpendicular for himself only. Okay, na? The L1 is not perpendicular to himself. Okay, sir. Hence this L1 comma L2, this L1 comma L1, not in my relation, sir. Not in my what relation, sir. Hence I can say it is what? It is not a it is what? It is not reflexive relation. Okay, it is not reflexive relation. Okay, sir. This is very heavy. Just wait a minute, students. You must be learn all the examples in this lecture only. Then you just must be take the decision. Okay, so let's just be on. Okay, sir. Okay, let's see the symmetric one here. Okay, what for a symmetric? Okay, let's say the symmetric one here. You can say, sir, for the symmetric one, if L1 let I can say if L1 and L2 are in relation, then then L2 ये let कर रहा हूँ, this is what this is, I'm just letting this thing. Okay, okay. Okay, let's see. So I am just take L1 and L2 as a relation here, and then I am just take L2 and L1 are also in my relation. I am just letting these values. Okay. So this is what this is something in my relation, but I just want to find that is also in my relation. If there is not in my relation, then I am saying this is not in my relation. Okay. Is L okay? So for L1 comma L2, I'm saying belongs to R, that is implies L1 is perpendicular to perpendicular to L2. That is very true, sir. Okay. If I take L2 comma L1, then I can say L2 is perpendicular to L1. L2 is perpendicular what to L1 here. Okay, sir. Then the both the statement actually true, because if I take L1, if I take this line L1 and I take this line this line L2, then I say these two lines are parallel. If I take this line L1 and this line L2, then these also are perpendicular na. If I take the reverse condition, then it is true only. So both the above condition are same. Both the above condition are same. Okay, so okay, sir, then if I say this, the reverse condition is also same, or I can say in my relation here, then I can say it is symmetric one. Okay, sir, it is symmetric relation. So that's all. That's about my symmetric one. So this is what symmetric relation, and here it is not in reflexive in nature. Okay, let's talk about the transitive one. Okay, we just take the upper side. Okay, transitive one. Okay, let's see transitive one. What is the transitive one? You just take two condition, if condition, and just try to prove the other condition. That is one condition, that is let if I can say L1 L2 are in my relation. Okay, and L2 L3 in my relation. Okay, there are some two other lines, and it must be this line and this line are must be same, and I can say L2 and L3 also in my relation. Then I can just say it must be what L1 L3 are also in my relation. I'm just wanting to find this or this, and take this pair and just try to find this condition is true or not. Okay, let's see. Okay, for L1 and L2, you can say this is what L1 is actually perpendicular. This is perpendicular sign, perpendicular to L2. That is true, sir. Okay, for L2 comma L3, that is what L2 is perpendicular to L3. Okay, let's take the condition here. Then I just draw the one diagram here for your better understanding. Okay, let's say this is what. Okay, let's say this is my L1 line here. Okay, this is my L1 line here, and I'm just saying L1 is perpendicular to L2. So here is my L2 line that is somewhat perpendicular to L1. Okay, for second condition I'm saying well, L2 is actually perpendicular to L3. So there is another line that I am taking just this. Okay, just this is my L3 line, which is also perpendicular to L2 line. Okay, sir. For more clear, if it is true, then it must be for transitive exactly. It must be L1 L comma 3, that is what L1 is perpendicular to L3 here. L1 is perpendicular, but from this diagram I can just show here that is L1 and L2 L3 are actually parallel lines. If I take these two condition L1 L2 and L2 L3 condition are here, then with this implies I'm just say for this transitive only I'm just saying L1 also be perpendicular to L3, but with this two condition I can say there have the lines L1 and L3 are parallel, which is contradictory statement, which is what we take L1 L3 as a line perpendicular, but with these two condition I am comes with result L1 L3 are parallel. That's why I'm just say it is not It is not a transitive in nature. Okay, sir. Sir, this is like I am just revolving around my whole world. Wait. This is somewhat the good example. Okay, I can just say the NCERT thing, or the NCERT even take the good examples to train your mind. Okay. So just wait and just try to solve more and more example in the transitive, or I can say the reflexive, symmetry, and transitive one. Okay, so it is not transitive relation. Okay, so what we can do, we can just show that that is R is symmetric, but neither reflexive nor transitive. That is our answer also. The set here is not my the relation here exactly is not reflexive but symmetric but not transitive. Okay sir. So that's all about this example only. Okay, let's take the one more. That is something about easy example. Okay, this is what you just very try to give, or I'm just say try to solve in just minutes. Okay, let's say show the relation RB the set. Okay, this is what RB in the set, this is what something that related with this set only. Okay, and the relation actually given to you, what that is something 1, 1, okay, 2, 2, okay, 3, 3, okay, 1, 2, and I can say 2, 3 here. Okay, let's see. Okay, can I say for the reflexive one? Okay, so what can I do? We just try to find if the relation part in given to you in a roster form, I can say the numbers form. So you what you can do, you just try to give the false condition. If there are no false condition, then it must be your reflexive relation. So is there any false condition are there? For this set, there are 3 identity relation must be 1, 1, 2, 2, 3, 3. Is there all the 3 identity relation are in there? You can say yes sir, 1, 1 are there, 2, 2 are there, and 3, 3 are there. So I can say all the elements, all the pairs for reflexive, okay, reflexive, just forget about spelling, reflexive are in my given relation, okay, that is you can say 1, 1, that is 1, 1, 2, 2, and 3, 3, which is belongs to my relation. Then I can say this is reflexive relation. Okay, this is what reflexive relation. Okay, that is what about the relation reflexive. Okay sir, let's take the symmetric one here. Okay, I take just change my pen here. That is symmetric one. Okay, so what is the symmetric here? So I can say what is our symmetric relation. I can just find one pair that is actually not are in your relation. Okay, so if I take 1, 1 pair, so is the reverse of 1, 1 RB there? You can say yes sir, itself reverse is 1, 1. 2, 2 is not is be there because the reverse are be there, and 3, 3 are reverse are be there. Okay, can I say 1, 2 are there? Okay, let's see. 1, 2 are in my relation, but for my symmetric 2, 1 are also be there. 2, 1 are also be there now for symmetry, because all the pairs that is exist in your relation, there must be reverse pair are also be there. Okay, so 1 or 1, 2 are on my relation. Then I can say then 2, 1 are not in my relation here. So this is the one false condition. You can take also 2, 3 here. You can take 2, 3 now. That is also a false condition. But for showing not symmetry, you just take one false condition, and that's all about it. Okay, so can you take this condition 1, 2 are in relation, but 2, 1 are not in our relation? So ultimately, this is not a symmetric relation. Okay, this is not a what? Symmetric relation. Okay sir. Okay, let's do the other pen and try to give the transitive one. Okay, so what the transitive one? For transitive one also, you just try to find what some example, or you can say some false condition are be there. If there are any false condition are be there, then I can say that is a transitive and not transitive in nature. If there are no false condition in there, then you can say this is a transitive function. Okay, so try to make the pairs. That is first second element or second pair for first element are same. So try to make. Okay, let's say I'm just take 1, 1 here and 1, 2 here. So these are my examples. I can just try to give in my rough work. This is my rough work, and I can say 1, 1 are in my relation. Yes sir. And 1, 2 are in my relation. Yes sir. Because these two examples are actually proving my transitive thing, because this 1 and 1. So for transitive thing, you must be taken that kind of pair that should be matched second element of the first pair and first element of the second pair. Okay, okay. So with this pair, you just implies with what pair? That is 1 comma 2, this one and this one. Okay, so is 1 comma 2 are also in my relation? You can say yes sir, 1 comma 2 are also in my relation. So that is what this is a true condition. You can say sir, this is true condition, so is it transitive now? I can say no, you must be aware and just try to find with the keen eyes the false condition here. Okay, let's find the false condition here. Okay, so let's say these two examples. Okay, let's say I'm just take 1 2 as a relation, belongs to in my relation. Okay sir, and I'm just take 2 comma 3 as in my relation. Okay sir, so the 2 or 2 are same, and ultimately what I'm saying, 1 comma 3 are also be in my relation. Is my 1 comma 3 are in my relation? You can say no sir, there is such a ghapla thing. Okay sir, this is the Hindi word. Okay, so yeah, I can take 2 and 2 same, but the pair is what? 1 comma 3. So is it not in my relation? That is not in my relation, sir. So that is what the some false condition. That one false condition are very good for my proving that relation is not transitive. So as it is, I am just giving the example here. So 1 comma 2 are in relation. Yes sir. Okay, and is 2 comma 3 are also in relation. Okay sir, but 1 comma 3 are not in my relation. So I can say this is not a transitive relation. Okay, what? Transitive relation. That's how the relation thing works. So this is one which is little easy with the past one. So that's how the shuffling of these questions. So you can just take the easy one also, some try to conceptual one also, and some difficult also. Okay, so that's how you train your mind, or you train yourself only. Okay, so okay, let's take the exact exercise 1.1 here, and we just take some questions from this exercise 1.1. Okay, let's say for the first example only, we just write to each of the following other relation are reflexive, symmetric, and we just determine the in this only. Okay, let's say if I take the relation R in the set, that is set A, and these are the set. Okay, and defined as R for what? This condition only. Okay, no problem sir. I can take this answer one first, and one thing students, I'm not writing here the whole statements. It is enough. I'm just taking the examples, or I can just explaining you with the previous examples. Okay, so the statement parts you already try to solve by your own. I'm just taking the logic here and just giving you that this is reflexive or not. Okay, that's how things works here. Okay, so if I can take the relation R, and that is in the set A. Okay, define as the relation R actually is what? With this condition only. That is what? 3x minus y equal to 0. So what I can do, I can just try to find firstly the relation sets. Okay, so what is the relation set here? Okay sir, okay, for the relation set, I can say I can take x 1 comma 3 here, because if I take x 1 comma 3 as a pair, so I can say 3 into 1 minus 3. So ultimately it is what? 0, or that's I want to with this condition only. So 1 comma 3 are my best suitable example for this. Okay sir, 1 comma 3 is my best suitable example. Okay, can I take 1 comma 3 here? Okay sir, no problem. Can I take, okay, so 1 comma 3 are here. Okay, let's see. Can I take 2 comma 6 here? That is also true sir, because if I take 2 here, then 6 minus 6 equals to 0. That's very true. Can I take 3 comma 9 here? That is also true sir, because the multiple of 3 I am taken, that's multiple of 3 ultimately minus with the y, and that comes with the 0 only here. Okay, can I take 4 comma 12 here? That is also true sir, because I just take this element, and this is what something. Can I take 5 comma ultimately 5 comma what? 5 comma 15 here? You can say no sir, because 15 are not actually in my A set here. Okay sir, so ultimately the relation basically comes in that first part. You can say 3x minus y equal to 0 here. Okay sir, okay, so what can I say? Is this reflexive or not? If this reflexive or not, and okay, so okay, reflexive or not, I can say symmetric or not, or I can say transitive or not. Okay, that is very easy one. Why? I can say the reflexive are not be there, because they have not a single pair. That is an identical. I am saying this is not a reflexive. So this is what for first one. Okay, can this is symmetric one? you can easily find one of the pair. That is, if I take 1 comma 3 as in is in relation, but 3 comma 1 are not be in there, so this is also not in my symmetric. So for the false condition, you just take only one false condition. Okay. Okay. Can I take transitive one? So you must be find the two set here, that is ultimately these two sets. Okay, what is 1 comma 3 are in relation, 3 comma 9 are in relation. Ultimately what pairs are also in my relation? 1 comma 9. Is there 1 comma 9 are in that relation? You can say no sir. So with this example only I can say this is also not a transitive relation. Okay. Okay. Okay, let's find out the second question here. Okay, so what is the second question? The set of the non-natural number. Let's take on the other page, and I can say my set basically my A set basically what? Set of all natural number. Okay, set of all natural number what? Set of all natural number basically is 1 comma 2 comma 3 and comma 4 and so on. Okay, no problem sir. Okay, if I take the condition here, what is the condition? I am take a relation actually the given. Okay, so whereas the relation actually x comma y and which represents what? X plus y. Okay, so what represents x? Okay, so not x plus y, that is y equal to x plus 5. Okay, so this is what? This is something y equal to x plus 5 and x less than 4, and should be x should be less than 4. That is the true condition here. Okay, for the condition that you must be find your relation. Okay. Okay, let's find the relation one here. Okay. Okay, can I take x equals to 1? You can say yes, because if I take x equals to 1, then y should be 6 here na, because I take y equal to, if I take x equals to 1, then y plus 5 1, that is 6, and x also 1 also less than 4, so this condition are also be there. Okay, so can I take 1 comma 6? That is very true. If I take x equals to 2, then 2 comma 7, because 2 are less than 4, then that is also be considerable. If I can say that 3 comma 8, that will also be considered because x is actually less than 3. Okay, can I say 4 comma 9 here? You can say no sir, because actually 4 is not less than 4, because 4 is not according to this condition na. If they are equal here, then we just might be taken what? The 4 element here, but for the x you not be taken as a 4. Okay, so this is what? This is the 3 pairs that is exist na. So easily you can say sir this is reflexive. No. Is this symmetric? No. Okay. Okay, is this transitive? I can say no, but you can say sir there are no pair that you can find and for transitive example. So if there are no pair or exist for the transitive one, then that relation are also not in transitive relation, are also not in transitive relation. So I can say for the second one, I can just say there are no reflection, no symmetric and no transitive. Okay. Okay, let's see the another one, that is the third part. Okay, that is very good. That is something you can say the set is 1 2 3 comma c and x and y, and something y is divisible by x here. Okay, so I can just take the another pen and I am just writing the set here. What? E set here, that is something set 1 2 1 2 6. Okay, 1 2 6, that is 1 2 3 4 5 and 6 here. Okay. Okay, let's see if I can take the R set here. And what is the R set here? That is ultimately x comma y, and it is represent what? Y is divisible by x. Okay, y is divisible by x. No problem sir. Okay, let's take the example here, and I'm just taking the y is divisible for a by okay. Without finding the relation, okay, I can say without finding the relation set here, I can just try to find out the reflexive one and the symmetric one. Okay. Okay, let's say the reflexive one again. Okay, without any what? Try to find the pairs. Okay, so where I should find pairs? I can say if there are any statement like this are be given in your relation, then you must be not taken the example, or I can say the relation as a whole number set, or I can say the statement must be used as of proving my reflexive, symmetric or transitive one. Okay. Okay, so if I can say x comma y is actually divisible by x. Okay, so if I let I take x comma x, because the reflexive one is what? Both the elements should be same. If I take the x comma x are in my reflexive, then it must be the condition. What says? Condition it says x is divisible by x. Okay. Okay, so above condition makes sense na. Above condition are true. our condition are what? Our condition are true because what? X is divisible by, yes, the own number is divisible by his own number, na? So I can say this condition actually holds true. So for this this condition, I'm just taking the assumption part, the variable part. So with the whole condition, you can say all the numbers. If I can take 1 1 2 2 3 3 4 4 5 5, so these all the pairs actually satisfy my condition. That is what y is divisible by x, na? So this is what? This is, I'm saying this is my reflexive relation. Okay, this is what? This is my reflexive one. Okay. Okay, sir, no problem, sir. Okay, let us take symmetric one here. If I take the symmetric one here and try to give you the more idea, and I'm just say take if condition here. Let if x comma y are in my relation, then y, then what? Y comma x are also in my relation. So what I am trying to find to prove, that is y comma x are also in my relation. Okay, this is the letting condition. Okay, let's say if I take x comma y are in relation, then it must be by what condition? With x is divisible by x. Okay, divisible by what? Not y is divisible by x here. Okay, this is a condition. Okay, for this, if I take y comma x, then r is in r, then it must be x is divisible by r. So is this holds actually true? I can say no. If I can say like I am just taking as an element like 1 comma 3, then or I can say the 2 comma 6 here. Okay, so you can say, sir, 6 is actually divisible by 2. Okay, so you can say, sir, 6 is divisible by 2 here. Okay, divisible by 2 here. Okay, sir. Okay, is this reverse are true? Actually, if I take 6 comma 2, so this is true or not? Is 2 is divisible by 6? It's 2 is divisible by 6. You say no, sir. You say no, sir. So I can just say for this question only, I'm just saying this. I'm just saying what? I am just saying above condition, above this condition, above condition, our condition not holds true. Not holds true condition. Okay, because the reverse actually not true. The reverse actually not true. So I can say this is what? This is something not symmetric. Okay, I can say this is something not symmetric here. Okay. Let's say the another one, and I'm just taking the another pen also, that is the transitive one here. Okay, sir. Okay, so if I just take let condition, and I can say if I take x comma y are in my relation, okay, and take y comma z are also are in my relation, okay, then it must be x comma z are also in my relation. Okay, sir. Okay, sir. So for x comma y, there must be what relation? That is y is divisible by x. Okay, that is the condition here. No problem, sir. If I take y comma z, then I'm just say z is divisible by x by y. Okay, then z is divisible by y. That is very true. Okay, sir. Okay, then you must be taken if y is divisible by x. Okay, if y is divisible by x, something like that. If I take what? Some take different. Okay, so if I take like this, if I take 2 comma 4 here, if I take 2 comma 4 here, and I'm just take 4 comma not 2 comma 4, there is some just wait a minute. If I take 2 comma 4 here and 2 comma 4, I'm just take one more example, that is 1 comma 3 here and the 3 comma 6 here. Okay, so let's find. Okay, for this condition, I'm just say is 3 is divisible by 1? You can say yes. Is 6 is divisible by 3? You can say yes. Ultimately for transitive, the number should be 1 comma 6. For this condition, you can say 6 is also divisible by 1 here. It means by this condition, by both above condition, and with the common sense, na, if y is divisible by x, if the z is divisible by y, then for the above condition I can say for x comma z are in relation, that is what something x above z is basically divisible by x here. So with this both condition actually belongs to this condition only, and that is actually true. By is common sense here. So I can say this is what? This is transitive. Okay, this is what? Transitive. That's how the things work for reflexive, symmetric and transitive one. Okay, So these all are the some good examples and some good questions for your practice only. Okay, sir. Okay. Okay, so if I take, let's take the fourth one here. That is what? That is something relation R in the set of all integers define as what? X minus y is an integer part. Okay, okay. Let's see the here only, and I can say what the set of all z. Okay, for all z, matlab for all integers. So students, there have this in this third question actually. What with the results we come out? That is something that is result that is the reflexive one, not symmetric one, but the transitive relation are here. So I can say for the third question, the reflexive relation is this. Yes. Is this symmetric relation? No. Okay. Is this transitive one? You can say yes. Okay. Okay. Let's take the fourth question here. And in the fourth question, you can say the relation are actually in the set of all integers. So what can I do for the all integers? You can say all integers like all the negative integers are here. 0 must be included there, and all the positive integers are also be there. Okay. Okay, what the relation actually defined in this question? You can say, sir, x comma y relation actually defined with x minus y must be my integer here. Okay, okay, let's take the fourth question here and just try to solve the fourth one. Okay, okay. If I say what my a set, actually my a set is what? My a set is all integers are here. All integers are here. No problem, sir. Okay, can I say for the relation? For relation, you can say, sir, x comma y, which represents what? X minus y is an integer here. Okay, okay. So this is what? This is somewhere what my relation condition. Okay, okay, sir. Okay, if I take x minus y as an integer, so is this a statement type question? You can say yes. So what can you do here? There is no need to just try to find all the pairs here, because the a set actually infinite set. Okay, so I'm not trying to find what all the pairs of the relation. I'm just trying to play with my statement and try to prove with my statement also. Okay, okay, sir. Okay, so let's take the reflexive one here. Okay, so for the reflexive one, what can I do for the reflexive one? Sir, very simple. You can just take the identity pair here, that is x comma x, and say let this is belongs to in R. Okay, if this is belongs to in R, then with the condition you can say, if you try to find x minus x, because this is something you can just replace y with the x na. Okay, so y with the x is what? X minus x is my 0, and I can say 0 is also an integer here, sir. Okay, sir. So sir, is I'm saying here what? Is I'm saying here this is what? This is something you can just try to find, that is 0 is also an integer. So x comma x actually, so hence, or you can therefore actually x comma x belongs to my R. Okay, sir. Okay, this is the letting condition, and I'm just try to prove this condition, and finally I can say therefore this x comma x are belongs to my relation here. So this is what? This is my reflexive one. So this is reflexive relation here. No problem, sir. Okay, sir. Okay, sir. Let's take symmetric one here. Okay, sir. If I take symmetric one here, then I can say very easily. What can I say? Let there one condition that is true for what? X comma y are in the relation. Yes, sir. And then what I am trying to prove, that y comma x are also in relation. Here. Okay, sir. No problem. Okay, sir. Let's say if I take x minus y, I can say x minus y is what? Is my integer. So I can say x minus y is my I. So I am just wanting that I'm just giving the integer here as a I. Okay, no problem, sir. Okay, if I try to find y comma x, then what can I do? I'm just trying to find is y minus x is also an integer. If this case is happen, then you can say y comma x are also in my relation. Okay, sir. Okay, sir. Try to find this. Okay, sir. Let's see if I take minus 1 here as a what common part. Okay, so can I say minus common? So this is what? Y minus x, and somewhere is I. Okay, can I shift minus here? You can say yes, sir. And this is what? This is y minus x is minus I. Okay, is this minus I is also integer? You can say yes, sir, because if I is all integer, whatever the integer, it's negative, it's positive, it's 0, then minus I is also integer. Now, if I take I as a positive integer, then minus I must be negative here. If I take I as a minus integer, then minus I must be positive here. So that's what? That I can say my y minus x is also an integer. Okay, sir. Therefore I can say say y actually belongs to what? Y actually belongs, not y, I'm just saying y comma x here. Okay sir, okay, let's see. If I take what, y comma x are also belong, therefore y comma x also belong to my relation here. That is somewhat beauty for the symmetric. So is this symmetric? You can say this is symmetric relation. Okay sir, okay. Let's take for the transitive one here. Okay, let's see with the another pen, and I can say transitive one here. Okay, so what is the transitive one? So sir, very simple, you just take two conditions that is true for this condition only. So I can say let if x comma y r belongs to my relation and y comma z r belongs to my relation, but or you can say then x comma z actually belongs to my relation. That is something you try to prove here. Okay, that is something you try to prove here. Okay, so no problem sir. Okay, so with this condition actually you can say sir x minus y is actually equal to my integer. Okay, no problem sir. Okay, with this condition I'm just saying y minus z is also my integer, and I'm just representing this integer with the capital Z here. Okay, no problem sir. Okay, so what can I do? I'm just trying to find x minus z. I'm just trying to find x minus z, and ultimately x minus z are also be my integer here only. Okay sir, so what can I do for this transitive one? I can say if I take this one is as a first equation and this one as a second equation, and just added both the equation first and second one. Okay, so that's the funda here for this, try to solve this type of the question. Okay, so what can I do? I'm just plus these equation, and for the equation plus addition thing, you can just take LHS part in the addition, RHS part in the addition. So I can say x minus y plus y minus z equals to I plus z here. Okay, that's the thing. Okay, so can I cancel this? Okay sir, and ultimately this is what, x minus z, and this is somewhere I plus z. Okay sir, what you do exactly in this question sir? Okay, let's student, you must hear this very clearly. Okay, what can I do? I'm just trying to find x minus y and try to find x minus y is what relation. Okay, so when I'm just practicing this question more and more, I have some sense in mathematics. If I plus this equation, then this equation by the addition for this equation, the x minus z r comes with the addition of these questions. That's how I learned these methods here. It's all about practicing or just sense things with taking a look of these types of the equations. Okay, so I'm just taking that sense, and what that sense, I'm just I'm just add 1 and 2, and after that the x minus z relation are here, and you can say sir I is my integer, z is my integer, the addition is also the integer here. Okay sir, so this is means x minus z is also an integer here. Okay, that is the something very clear. Okay, if x minus z is also an integer, therefore I can say x comma z are also belongs to my relation here. Okay sir, this is what, something good. So is this transitive? You can say this is transitive relation. This is what, transitive relation here. Okay sir, so in this question you can say the fourth one actually is what? The fourth one actually is my what, reflexive, symmetric and transitive one. Okay sir, okay, let's see for the fifth one. Okay, so I take fifth question as a verbal solution. You just try to give the statement by your own and by in your homework. Okay, but I am trying to say to solving by verbally or solving with this with this in your mind. Okay, so let's say for the A question, and firstly I just read the question here. That is what, the relation are in the set of A of human beings, okay, in a town at a particular time. Okay, I am just taking the set of the human being that is in a town at a particular time, and I can say given by, this is first the relation here, and I can say the relation here is what, x and y working at the same place. Okay sir, let's say if I take the reflexive one here. Okay, so for the reflexive one you just take the same elements, or I can say the identity set are you have to take for the reflexive one. You can say yes sir. Okay, so if I take the identity one, then the condition will also be like there, like x and x working at the same place. Okay, is this make sense, and does this make any sense? You can say yes sir. If I I'm just told you me and me are taught exactly the relation function to you. Okay, so is this any sense? You can say yes. If I take me as many more time, then it's not means some else taught you what, certain relations, or I can say relation and function. So what can I do for this? So I can must be say x and x are working at the same place now. Yes sir. So is this reflexive relation? You can say yes sir. So the reflexive things are clear. Okay sir. Let's say for the symmetric one. Symmetric one is what? If I take x comma y in the relation, but what I'm trying to prove for y comma x here. Okay. So for x comma y, you can say x and y are working at the same place. Okay. Can I take reverse order here? You can say y and x are at work at the same place. You can say yes sir. Why? Because actually the order are not matter na there. They're both the person are actually working at the same place. So if I take x comma y, if I take y comma x, both the things condition are true here. So I can say is this symmetric relation? You can say yes sir. So this is what? This is symmetric also. So for the fifth A condition actually you can say this is what? Reflexive? Yes. This is symmetric? Yes. Okay. Okay, let's say for the transitive one. For the transitive one, I'm just take the condition here, and I can say x and y work at the same place, and also for y and x, I can say y and z are also are work at same place, here. Okay, sir. Okay, if like I am just saying because we take two pairs na, and ultimately try to prove for the third pair. Okay, if I take x and y work at the same place, and yz work at the same place. Okay, so can I take x and z also work at the same? Yes sir, because y actually where the y actually work, the place of x. Okay, and z actually work at the place of y. Okay sir, that it means x and z are also work at the same place. It is a very obvious and logical now. So you can say sir, for x comma y it is also applicable. So I can say this is also something transitive one here. Okay sir. Okay, let's see for what the B question here, and I can say for x and y live in a exactly same locality. Okay, that is somewhere very similar to my A part here, and that is something you can say the exactly same. Okay, so x and x live in the same locality. You can say yes. X and y if they live in same locality, then y and x also is live in the same locality. If for transitive one, x comma y live in the same locality, y comma z live in the same locality, and it is obvious that x comma z also live in my same locality here. Okay, so that is something you already done in your previous part. Okay, so let's say the C part here, and I can say the relation actually is what? The relation is x is exactly 7 meters taller than y. Okay, let's see for this question only. Okay, let's see for this question only, and I can say for the fifth part and C, and I can say the relation here is what? The relation here x comma y, which represents what? X is 7 meter, or I can say 7 centimeter. No, not meter here. Okay. So x is exactly 7 centimeter taller than y here. Okay sir, no problem sir. So can I take this as a reflexive one? Let's see. I'm just not taking whole statement there. I'm just try to find the idea, but the statement part you must be given in your board exams, or I can say the whatever exams, the written exams actually may follow you. If you take as a what JEE exam, then it must be like you just take a logic, and you must be taken what is the the answer is what is this relation actually reflexive, symmetric, or transitive one. Okay sir. Okay, can I take x is exactly 7 centimeter? Just go with the logic. Okay, if I take the reflexive one, then what can I do? I can say what the x comma x are in my relation. That's what I'm trying to prove. Okay, for this condition, you can say x is exactly 7 centimeter taller than x. If I take like that, me is exactly 7 meter taller than x. Is this the logical statement? You can say no sir. My height with me actually equal. It's not 7 centimeter taller, or 7 centimeter shorter. It's actually equal to me. Okay, if I take a reference me with me. Okay, so is this reflexive? You can say no. Okay, so whatever you do with the statement here only. Okay, can I say the symmetric one? Okay, let's say for the x and y, you can say x is exactly what? Exactly 7 centimeter taller than y here. Okay, let's just think and take 2 to 3 seconds here. Okay, so 1, 2, 3, 2 more seconds, 5, 4, sorry, 5. Okay, okay, time over. Okay, what can I do you the answer here? So I think the 90% of the students are here comes with the answer only. Okay, so for y comma x is the statement is reserved the reverse here, that is what y is exactly 7 centimeter taller than what x here. Is this possible? Is this reverse thing possible here? You can say no sir. If I'm saying my brother actually taller than me, what 7 centimeter, can I say in the reverse manner my brother says my younger brother actually taller than me as a 7? No, that this is the fixed condition that have you taken must be there. So if I reverse this element here, then it's a true condition, then you can say no. So this is not a symmetric one. Okay sir, so this is not a symmetric one. Let's say for the transitive relation, that let's say for the transitive one. Okay, for the transitive one you can say x comma y, what x comma y, x is 7 centimeter taller than y. Okay sir, no problem sir. Okay, for y comma z here, what I can say y x exactly is 7 centimeter taller than what taller than z here. Okay, let's say me and my two elder brothers are here. Okay, me and my two elder sisters are here, and I can say my one of the elder if I can say in the series I'm with my elder brothers or elder brother, I can just take series, that is me is a x and one other taller brother is y and one other taller brother is z here only. Okay, so I can say or my other taller brother can say that is y, that is something you can say I can say okay, if I take this type of only, then y is actually taller than x here. Okay, let's take the reverse order. Then my the taller brother here is my x, the reverse order, and I take y, and in the reverse order I can take z here. Okay, this is the suitable example for this question only. Okay, so my actually older brother actually is what is something it's something that he is taller than y1. Okay, he is taller than y1, and y is actually taller than what z1, that is me. Okay, no problem. Okay, if I take my older brother and me, okay, the older one brother and me, what is the difference of me and my taller brother height there? You can say 14 centimeter. Okay sir, so for x comma z here is exactly is what you can say x is 14 centimeter taller than y, taller than what, taller than z here. So is this condition is true? You can say no sir. For this condition, for this transitive one, there must be x is 7 meter taller than z na. So this is the condition comes with these above two conditions only. So is this transitive one? You can say no. Okay sir. So this reflection is what, not reflexive, not symmetric, not transitive one. Okay sir. Let's see. So the C condition are here. Okay sir, if I take the D part here, that is very easy. Okay, for the reflexive one I can say x comma x. So what is the x comma x relation are here? You can say x is the wife of x. Is this possible? Is this logic? You can say no. So this is not a reflexive one. Okay, can I take in the reverse order? If I take x is a wife of y, then I can also say y is a wife of x. You can say no sir, the reverse order are not also be there. Okay, so this is not the symmetric one here. Okay, so this is not a symmetric. Okay, for the B C relation, you can say this is not a reflexive, this is not a symmetric, this is not a transitive one. Okay, so for this is not reflexive, this is not symmetric one. Okay, can I take x is just take for transitive one and see the upper side of your screen. X is what? X is the wife of y. X is the wife of y. Okay, can I take y is wife of z? So is this statement actually holds there? You can say no sir, because the husband wife relation are only one relation are here. Okay, and it is unnecessary statement, that is y comma. So I can say y comma z are also not in my relation. I can say the y comma z are also not in relation. It just means like that you have no pair to what just compare the transitive one relation here. Okay sir, okay, so it means there have no pair here, that I am just comparing what transitive relation here. Okay, so if the transitive one relation not comparing here, so I can easily say this is not at all transitive relation here. Okay, okay sir, okay. So something, this is your homework and you just try to think by your own, and I am just 100% sure if you take this car classes seriously, then you must comes with the correct answer here only. Okay, okay sir. Okay, let's see what some other questions. Okay, let's say for the second one question, that is also from the NCERT one, that is I can take, show that the relation R, okay, in the set R of real numbers. Let's say for the real numbers, okay, defined as what? Defined as, you can say the relation here, the set is what? The A set actually defines is what? The set of all real numbers. You can say all the numbers which exist in real form, that be taken for a set. Okay, so what was my my relation here is what? A comma B, that is something represents with A less than B square. Okay, okay, so what can I do? It is neither reflexive nor symmetric nor transitive. What can I do? I'm just taking those elements, or I'm just taking try to prove the false condition here only, and just try to prove this question here. Okay, okay sir. So sir, what can I do? Just I'm taking what? The reflexive one here. Okay, so the reflexive one, what is the reflexive one here? You can say, sir, you can say for the reflexive one here only, I can say what is A less than B square. Okay, I'm just trying to give those examples that is in a false condition, and what you can do, just show that. So this is what? This is something reflexive, not symmetric, not that is necessary condition, because you not try to find the conditions, you try to show these conditions only, that is this actual relation is not reflexive, not symmetric, not transitive one. Okay, okay sir. Let's say for the reflexive one, I'm just trying to find those conditions. So for those conditions, you can say let A comma A are in my relation, and just try to find one false condition here. Okay, okay, okay. So for all integers, for all real numbers. Okay sir, so if you have a mind and if you have something, you just take, sir, this condition something is true, because the A square must be greater than A square, na? That is something I just if I take 1, then I'm just taking if I take the pair what 1 comma 1. Okay, let's see if I take 1 comma 1. So you can say by this condition only, the A actually because the reflexive one are both the elements are same, na? So you can say 1 actually less than 1 square and 1 less than equal to 1. That is true, na sir? If I take negative 1, if I take like -1 or -1, okay, this is also true. 2 also true. If I take 2 also true. Okay, so for this only, you can take all the elements of real number set. Okay, okay. So what can I do here? I'm just taking natural numbers here, but not all fractional part. Okay sir, one false condition are in my mind. Okay, let's see. I'm just take 1 by 3 comma 1 by 3. Let's see. Okay, let's try to find this condition 1 comma 3. Okay, let's say if I try to 1 by 3, then I can say 1 by 3 actually less than equal to 1 by 3 square. Is this true or not? You can say 1 by 3 here, and you can say 1 by 9. Is 1 by 3 greater or 1 by 9 greater? Okay, can I find 1 by 9? You can say, sir, 1 by 9 is something 0.1111. Okay, and if I take the 1 by 3 here, then I can say 0.3333 here. So is this 0.33 is greater or 0.1 is greater? You can say, sir, actually 0.3. So the sign is actually like this only. Okay sir, so exactly this condition are failed to prove in there. For what? For 1 by 3 comma 1 by 3. Why I'm taking 1 by 3 comma 1 by 3? Because I'm taking a whole set as a real number set, na? So this is what my contradictory condition, and only one contradiction condition enough to prove that is not reflexive one. So I can say not reflexive. Okay, okay sir, okay. Let's say the symmetric one here, and I'm just changing my pen. Okay. Let's take for the symmetric one here, and I'm just take symmetric one for what? Let's say let A comma B are in my real number, or not real number, are in my belongs to rational, not rational, it's a relation here. Okay, then I can say B comma A are also in my relation here. Okay, let's try to find. Okay, for A comma B, for the A comma B condition here is what? A greater than B square. So what can I do? I'm just taking the what? Something example, or I can say something contradictory condition that must be taken here. Okay, let's do that. Let's can I take 1 comma 2 here? Okay, let's see. Is 1 comma 2 are satisfied with this condition? You can say yes sir, because 1 comma 2 condition is what? 1 less than 2 square, or something is 1 less than 4. So is this condition true? Okay sir. I can take reverse order here for this, for what? For proving my symmetric part only. So I can say 2 comma 1 here. That is something implies what? 2 actually less than 1 square. Is this statement actually true? You can say no sir, because 2 are greater here. So this is also the false condition, or I can say the false symmetric one condition. Okay sir, so this is not a symmetric here. So I can take the example that is contradictory condition. So I can say if I can take 1 comma 2 that is in relation, ultimately it's what? It's 1 less than 4 square there. Okay. If I take 2 comma 1, 2 comma 1 is in my relation, then it says what? 2 is actually not greater than 1 square. Okay, 2 is not less than actually 1 square. So this is not in my relation here. Okay sir, whatever way you can just writing there in your own form, you must be understand with your logic, or you must be understand with your method only. Okay, then you can just try to by your own way. I'm 100% sure examiner giving you a full marks be there. Okay, you can see sir, in the previous question you just try to by the other method, or you just try to give the solution by other method. In this question you just try to give the other method. This is something what you practicing size or a lot in this chapter only. Or I can say you just take the logic one, firstly understand the logic one, then whatever way you can write. Okay sir, so is this not? So I can say this is not my symmetric function here. Symmetric what symmetric relation here. Okay sir. Let's try to find what? Transitive one. Okay, let's see to the upper part of the screen. Okay, I'm just trying to rough all the part here. Okay, so let's see the transitive one here only. Okay, if I take the transitive one for this relation only. Okay sir, what can I do? I am just taking let what a comma b are in my relation, and take b comma c are also in my relation. Okay, and taking all those examples, and then b c comma a c, then a comma c are also in my relation. That what can I do? What can I prove for this relation only? Okay sir, no problem. Then what can I do? I am just taking the contradictory condition here and try to prove this is not a transitive one. Okay sir, let's see, this is not a transitive one, or this is a transitive one. Okay, let's see. If I take some example here, and I just take okay, let's say something, some example that is minus 2 comma 0, because I just take negative integers here. Okay, minus 2 comma 0, and I am just saying let's say the 0 and 1 here. So this pair is acceptable. You can say yes, for this pair, is this pair actually holds to this condition? You can say yes sir, because minus 2 actually less than 0 square. Okay, if I take this pair, then this is what? 0 actually less than 1 square. So ultimately with this pair, what can I do? Minus 2 comma 1. So is this minus 2 comma 1 also holds my condition? You can say yes sir, because something minus 2, something what? Minus 2 less than 1 square here. Okay, so this is what? This is the true condition. So what can I do? I can just do with my false condition here only. Okay sir. Okay, so what can I do here? Just think about this. Okay sir, let's see something, the example here, some example here that is must be taken by what? By something as a relation only. Okay, can I take minus 2 comma 0? No problem, minus 2 comma 0, that is the must be taken here only, and something minus 2. And if I take minus 3 here, then it must be I'm just trying to give the answer in my head only. Okay, in my head only I'm just trying to give the answers in this question as well. Okay, let's take the positive number, and take the negative one here. Okay, let's take 2 comma 3 here. Let's take the 2 comma or not take the 2 comma 3 here. Okay, and then just take 3 comma okay, let's see that the 3 comma if I take 3 comma minus 3, then it must be okay, then I just take 2 comma minus 1, let's say the minus 3 here. Okay, let's say the minus 3 here, and I'm just take minus 3 here, or something that is 1 here. Okay, so this is what? This is the false condition that I'm taken for this example only. Let's say If I take 2 comma minus 3, is this condition actually fulfills your condition? You can say yes sir, because somewhere what, 2 is less than minus 3 square, that is something 2 is less than my 9, no problem sir. Okay, is this condition also fulfills here? You can say yes, because minus 3 actually less than and 1 is square, and it is minus 3 less than 1 here. So what can I do? I'm just trying to prove what, 2 comma 1 condition here. Okay, so what this 2 comma 1 condition holds? You can say sir, 2 actually less than 1 square, that is true. You can say no sir, so that is something the contradictory condition I can take for this example only. Okay sir, okay. So that's how, that's this thing simple for you guys. Okay, so this is something I can take. I can say 2 comma minus 3 is in relation, and this must be follow my condition, that is 2 less than minus 3 ka 3 whole square, that is 2 less than 9 here only. Okay, if I take minus 3 1, then you can say it is also in relation, because something what, it is minus 3 less than 1 square, and this is true, that is what, minus 3 less than 1. But I can say 2 comma 1 is not in my relation. I can say 2 comma 1 is not in my relation here, because 2 exactly not holds this condition here only. Okay sir, so is this transitive one? You can say this is not a transitive relation, this is not a transitive relation. So sir, something good in this question, and I can say the good one for taking the examples or the false condition here. Okay sir. Okay, so this is something you can just take by your own. Okay, let's take by the third question here, and this is something take homework to you. Okay, this is something you just try to make what, this is not a statement types of question. You just try to make all the pairs here. Just take A as a 1, then the 1 2 are pair are be there, then must be taken 2, then must be taken 3, must be taken 4, must be taken 5. But if I take the 6 as a, then B must come with 7. That 6 comma 7 actually exists. You can say no, because 7 exactly not exists is my original set here. So with this whole set, or I can say the whole relation, that you must be find the set is in reflexive or not, or symmetric or not, or transitive or not. Just check these the relation types here only. Okay, so this is something homework to you guys. Okay sir. Okay, if I take the fourth one here, what is to show that the relation R in R define as, and what, this is the something, and this is reflexive and transitive. Okay, so this is something also very simple. You must take an, this is something to show you. You just show the reflexive one here, but and transitive one here, but not symmetric. So all the condition for reflexive and transitive must be true here, but I'm just wanting the false condition for symmetric one. Here. Okay, so you must be taken reflexive condition here, you must be taken the transitive one, and try to show by your own way, and but try to solve also, it's not a symmetric one here. Okay, so this is something the homework for you guys. Okay, let's say for this one. Okay, so if I take this example, if I take this question, or I can say the second one question is something that that's something very similar to the second one also. Okay, check whether it is reflexive, symmetric, or transitive here. Okay, the relation defined with capital R is what, is my real number sign. Okay, it's my real number sign here only. Okay sir, so what can I do sir? If I take all these examples for this question also, you can say exactly all these examples are maybe valid or not valid for this one. Okay, so what can you do? You can just take this question also as a homework. Okay, very easy. The reflexive one, you just try to find the that pair which is not reflexive. If you not find this reflexive one pair, then you can say this is reflexive. If you find the false condition here, then it's not be reflexive, not be symmetric, and maybe not be transitive here. Okay, so that's you show for this question here only, and that is also homework. So something you also have to do now. If I just give you a platter to you and just try to give not any options, and I'm just say you just eat this paneer, this matar pulav, or I can say the chicken here. So all these things I am just serving you as a platter. Now you can do some homework, or you can do some thing for that amazing platter that I have to serve you. Okay sir. Okay, So let's take the sixth one question here, and I can say show that the relation R be the set actually 1, 2, 3 here. Okay. Given that R is this relation, that is very simple. Okay. I'm just trying to do in what? In 30 seconds here only. Okay. This is the relation that's come from this set only. Okay. What can I do? Just show that this is symmetric one, but not reflexive, not transitive. Okay. Let's say for the reflexive, you can say, sir, there are no identity pairs are here. So ultimately, I can easily say this relation actually not reflexive. Okay. Okay. Can I take symmetric one? You can say, sir, you can say there are only one pair and the only two pair are here, and the pair are in reverse order. So if I take 1, 2, then 2, 1 are exist, and if I take 2, 1, then 1, 2 are also exist. So is this symmetric one? You can say yes, sir. You can say yes, sir, because all those pair are actually in reversing order. Okay, so my symmetric relation are this. Okay, okay. Can I say the transitive one here? You can say no, so because these pair are only the pairs that I have take for proving the transitive one. So I can say 1, 2 are in my relation, 2, 1 are in my relation. That 1, 1 should be in my relation, but it is not in my relation here only. Okay, so it is not exactly in my relation here. So can this transitive one is not, it is transitive one? No, sir, this relation is also not transitive here. Okay, okay, something very interesting. Okay, okay. Okay, let's say for this example, and this is something very easy example. Let's try to find this example only. Okay, let's say S be the set of all real numbers. Okay, no problem, sir. And R be relation with the S. Okay, so basically S is my head of the set, and I'm trying to find or take all those elements in the set A only. Okay, so I can say S actually is what? All real numbers here. Okay, all real numbers here. No problem. Is defined by, there have the some relation here, that is what? A comma B, and that is something represented with 1 plus A into B, that is greater than 0. Okay, no problem, sir. What I am trying to show that is this relation actually is reflexive and symmetric, but not transitive here. Okay, but not transitive here. Let's say for the reflexive one here. Okay, let's say for the reflexive one, and I can just do here, what can I do? I'm just trying to find reflexive. So let A comma A what? A comma A in my relation, that is what I try to find there. Okay, okay. Let's say I'm just taking the false condition here. Okay, I'm just taking the false condition here, and what can I do? I'm just try to prove the reflexive one. Okay, if I take all the pairs, that is something I can take maybe 0, 0, and maybe negative pairs are also be there, and maybe the 1, 1 positive pairs are there. So if this pair are satisfied, if this pair are satisfied, and this pair are satisfied, or I can take the some fractional part also, that is 1 by 2, 1 by 2. Okay, if these all parts are satisfied now, then I'm just saying okay, let's see for A comma A. Okay, for A comma A, you just taken what condition? For A comma A, if the A comma A are in relation, then it must be like this: 1 plus A into A is what? 1 plus, oh no, that is not A into A square, actually A into A only. Okay, for instead of B, I can just take an A here. Okay, so this is A square. Okay, by logical, you can say 1 plus A square always greater than 0. By logical, you can say 1 plus A square always greater than 0. Why? Because if I take 0 here only, if I take maybe A as a 0, then and this whole expression comes with 1. If I take a negative here, then with the squaring thing, the part actually A square comes with positive part and must be added with 1, then it must be greater than 0. If I take positive 1, then it's obvious that 1 plus A square must be positive. So if 1 plus A square, hence, or I can say therefore A comma A are in my relation here. Okay, so sir, this is one that is in reflexive one. Okay, sir. Okay. That is something cool. Okay, so this is what? This is the reflexive function here only. Okay. Let's say for the symmetric one. Okay, sir. For symmetric, what can I do? Let's say I am just taking A comma B are in my relation. Then if the A comma in my relation, then it's try to prove for B comma in A are in my relation. Okay. If I take one A comma B are in my relation, then it must be implies that what? 1 plus A into B greater than 0. Okay. For B comma A, the expression should be like 1 plus B into A. Okay. Is 1 plus B into A is also greater than 0? Yes, sir. Because if I just reverse this order by there now, then you can say this is also 1 plus BA greater than 0. okay, because I'm just reversing multiply order na, and multiply thing is not dependent with order only. If I take 1 into 2 and if I take 2 into 1, that's answer must be my 2 here only, okay. So this is something you can say 1 plus BA also greater than 0, hence or therefore you can say B comma A are also in my relation, and I can say this is also something symmetric also. Okay sir, okay sir, okay. Let's take the transitive one here, okay. Let's say the transitive one and just try to find the transitive one. Okay sir, let's say the transitive one. If I can say the for the transitive, no, whereas what can I show that not transitive, okay. Let's see if I take if A comma B something are in my relation, okay, no problem sir, and I am just take B comma C also something in my relation, okay, then it must be what, it must be A comma C also in my relation here, that is something very good, okay. Let's say if I take 1 comma B and 1 comma B in relation, then something is 1 plus B into A less than 0, okay. If I take B comma C here, then something is what 1 plus what B into that is A into B, and that is B into C, that is less than 0. If I try to these calculation here, then I am not taking as a part for proving the transitive one, not transitive one, okay. For not transitive one, I am just taking the false condition here, and I am just taking one example only here, okay. I am not try to do the one what is the not transitive one, okay. Let's see what is the not transitive one relation are here, okay. So if I take something like this, if I take like my previous examples, and I'm just trying to find the false condition, because here this example can say this is my not transitive condition here, okay. Let's see -2 comma 0, okay, no -2 comma 0 because there have something, okay. Let's say -2 comma 0 here, okay, let's say, okay, and I am just taking 0 comma 3 here only, okay. I am just taking 0 comma 3, then let's say -2 comma 0, is this condition is fulfilled? You can say yes sir, because 1 plus what -2 into 0, is this greater than 0? You can just say yes, because this is something 0, that is 1 plus 0, and this is something greater than 0. Is this condition also satisfied? You can say yes sir, because 1 plus 0 into 3 also 1 plus 0, that is something greater than 0, okay. Is my -2 comma 3 condition are also fulfilled there? You can say, let's see 1 plus -2 and into 3, okay, no problem sir, and that is something 1 minus 6 here, and 1 minus 6 is what? 1 minus 6 is -5, and something -5 is not greater than 0, maybe the 0 is greater than here, okay sir. So this is what something, or you can say this is not greater than that, okay. This is -5 actually not greater than 0 here, so something which is contradictory condition. So what can I do? I am just taken as an example as a false condition here. So I am just taking what, if I take 1 comma 2 here, that is something in my relation, that is something implies what 1 plus -2 comma into 0, that is something greater than 0, and I can say 0 comma 3 here, that is in my relationship not relationship. I can say 1 plus 0 into 3 here, that is also greater than 0, okay. But -2 comma 3 are not in my relation. Why? Because 1 plus -2 into 3 not greater than equal to 0, not greater than 0 here, because ultimately this answer comes with -5 not greater than 0 here. So actually -2 comma 3 are not in my relation here. So I can say this is what, this is the transitive one relation, okay sir. Oh, not transitive one, okay, this is not my transitive one. So I can easily show here that is this relation is reflexive one, this relation is a symmetric one, but not transitive one over here, okay sir. Okay. This is the last question that I am doing for this class only. So you must be feeling like this class is very long. It must be long, because there are many examples and there are many question solving for your understanding only, or understanding only. Why? Because if you take just take the definition part na, then must be there have no other chances. You have to you have no understanding with this definition only, okay sir. Okay, let's say the 12th example first part, and I'm just taking the given example in the relation, okay. With this example, I'm just take one universal set, or I can say the A set here, that is something 1 2 3, okay. I'm just give the short example here and try to quickly wrap up this lecture only. Okay. If I take this here and I can say give an example or give those relations actually, give those relation actually that is actually on this way only. Okay, on this way only. What that way? I can say the first one, that is this example may be reflexive and transitive but not symmetric. Okay, let's say for the relation. Okay, so what can I do? I'm just taken all the identity elements here. So it's if it is relation is reflexive, then I must be taken all the identity pairs are here. Okay, so is this reflexive? You can say yes. Okay, so I'm just taking the transitive one and I'm just taking those pair. That is also in there only. So I can say if I take 2, 3 pair, take 2, 3 pair, then it must be there only. So you can say, sir, yes, because this is something that is transitive also, because if I take the try to prove transitive one, then I'm just must be taken as a pair that is something like this or this maybe. Okay, so if I take this pair, then I'm just say this 2 or 2 exactly similar, then 2, 3 are also in my relation set. So is it there? You can say yes. Can I take this pair for proving transitive one? You can say yes, sir. If I take 2, 3 here and 3, 3 also here, then this 3 are be similar. Then I can say what? The 2, 3 are also be there. So it's 2, 3 also be there. Yes. So is this relation actually transitive one? You can say yes. Is this relation are not symmetric? You can say yes, sir, because there are no pair which have in relation that's the reverse pair here. What 2, 3 reverse is what 3, 2, and the 3, 2 are not be there. So this is the one of the example that is not reflexive, transitive but not symmetric here. Okay, so you can try to give more examples by your own also. Okay, so let's say the second one, that is what symmetric and transitive one but not reflexive one here. Okay, let's say the R here. So if I take the not reflexive one, then I must be taken not any single pair of identity pair. Okay. Let's say if I take 1, 2 here, and let's say 2, 1 here, and I'm just take 1, 1 also here. Okay, so what this relation actually say? Is this reflexive? You can say no, because 2, 2 and 3, 3 are missing there. Okay, sir. Okay, let's say for the symmetric one, you can say, sir, 1, 2 reverse pair are also be there. You can say yes. 2, 1 reverse pair also be there. You can say yes. 1, 1 reverse pair also be there. You can say yes, sir. Okay. If I take transitive one, then I must be taken the pairs here. So can I take this pair? Okay, sir. You just take this pair for the proving the transitive one. So you can say that this 2 and 2 are what? Are same. Then 1, 1 are must be in this relation. This is also true. Okay. Can I take this pair or this pair also? Yes, sir, because 1 or 1 are also same. Then 2, 1 are also be in this pair, in this relation. You can say yes, sir. Okay. Can I take this pair also? You can say yes, sir. The 1 and 1, the what? 1, 1 and 1, 2 are must be taken. You can say 1 and 1 are same, and ultimately 1, 2 are here only. So this is what? This is something symmetric and transitive but not reflexive. So this is all about taking the examples thing. So what can you do? You just take examples for these 3 only as a only homework. So something you just learn in this class, you must be taken for these questions only. I think this is enough for you for this lecture. Actually, I'm just taking bye from my side. I'm not taking so much time because this lecture is must be like out of limit of your way or my way also. So without any words, I'm just taking bye from my side, and let's see in my another lecture. So bye bye, tata, see ya. Let's see in the next lecture. Okay, bye bye.